Good morning, good afternoon, good evening, viewer, wherever you are. Welcome to the Introduction to Research for Geomatics Engineering student. For the targeted audience, those who are interested in geomatics engineering field, or basically you are a final year student within the GIS section or geomatics engineering student. I'll be taking us through an introduction to research. My name is Isaiah Wanyama. We'll be going through a practical guide on how to formulate and how to do your project design, basically the scientific inquiry. And in this session, I'll introduce you to the core concept and practical steps involved in conducting a research with a focus on principles applicable for geomatics engineering. What is research? Beyond simply finding out about something or scientific inquiry, this is a systematic process in which you get to find more details about a specific field of interest. And in our context, we'll be focusing on the scientific inquiry within the geospatial industry. And scientific inquiry has been defined as the experience of carefully planned in advance, finding out about something and updating everyone's thinking in a response to more and even a better information. The ultimate purpose of scientific inquiry is to develop, understand, and support improvement within the field of science. Research in geomatics engineering, an overview. Geomatics engineering project involved gathering field information and measurements. And some of the key tools that I use, we have the recent Global Navigation Satellite System, the GNSS. We also have the total station, we have the robotic one, and we also have the manual one. We have the aerial survey, or basically a combination of all these tools. We also have the former instruments that have been used for data collection, like the theodolite. We have the digital level, a new advancement within the leveling discipline. And as we go through the research process, we are trying to answer a few questions. And some of the questions that are involved in research for geomatics engineering, you have three questions which determines the choice of your objectives. Your topic statement informs a bigger part of how you're going to formulate your objectives when it comes to a final year project. Choosing a topic. This is the key and probably one of the most hardest part of our research process. And it really informs what you're going to do. And my advice will be work on a topic that genuinely interests you. Give yourself time to read around the field and develop a view of the current position, or called the state of art, before finalizing your topic. You will have to use some of the recent research website. You can use the Google Scholar, you can use the MDPI platform, you can also use the ResearchGate platform to go through some of the research paper within a specific niche that you are interested in. After considerable time of trying to read the abstract, trying to read through the document, you are able to come up with a topic. It's more of an iterative process that may take you even a week based on the time you have given. And choose a problem that you can confidently solve to some extent, ensuring that both a positive and a negative result will yield something useful for your write-up. And after going through some research papers, and even after going through some published book on research analysis, it's evident that your hypothesis may be wrong. So you have to do it open-mindedly and doing it with an willing mind to with an open mind to see what has been written. And it's generally more productive to extend existing work than just launching on your own field entirely or the uncharted territory. So it's an invitation for you as a researcher, for you as a geomatic engineer, as a GIS analyst, or basically a geospatial guy who is interested in this field, to give much of your time and choosing a specific topic that you are interested in, and in something that has already been done and researched on. When it comes to novel idea, the major challenge becomes when it comes when you decide to do your literature review. You'll not have a backup, and for most of the research work you need a minimum of 40 research paper up to 50 research paper. So it's advisable that you do consider choosing an area that has existing literature work. When it comes to formulating your hypothesis, you can begin with your research journey in several ways, often leading to the formulation of an informed hypothesis. First, you have to begin with a prediction. If you already have an idea about a potential solution to a problem or an answer to a question, the next step is begin by asking questions. Devote time to ask questions to clarify your interest and zero into what you want to study. Once you can imagine an answer, move to making predictions. Then begin with a research problem. Start by clearly stating a problem you want to investigate. Asking questions about this problem will naturally lead you to guess or to make predictions. Regardless of where you start, the aim is to develop predictions and rationales that put you squarely on the path of scientific inquiry. So basically, these three steps are key when it comes to you formulating an hypothesis. And it's a whole iterative process that you may need, or you will need to take a considerable time even as you try to formulate your research question. Developing a theoretical framework. Definition: a custom-made theory that specifically focuses on the hypothesis you want to test and the research questions you want to answer. It explains why your predictions are plausible. Are they workable? Are they feasible when it comes to you doing them? It's a built up from what is already known through the published empirical evidence and existing theory. Your framework should be as clean and frugal as possible, including only ideas and data directly relevant to making your framework stronger. Why you need theoretical framework? And basically here are four sound um, points that you can consider. Ensure your sound reasons for your prediction, help craft appropriate methods and guide the interpretation of your data. Show the contribution of your study to the field. These are key 4 points when it comes to making your theoretical framework. The power of asking why and refining the hypothesis. Continuously ask why for your predictions and subsequent reason. It's a very powerful thought process that builds your rationale. And going through a panel session where we have a number of lecturers and professors listening to your work, one of the questions you are likely to be asked is, why did you choose that method to do your work, or why did you choose that specific topic? So always be prepared with a why behind every part of your literature work, and even the results, why that results. And this should be majorly informed by your literature review. So when it comes to your theoretical framework, it's a key part when you're working on your project. And remembering that the place of asking questions is a whole iterative process, and you have to make them as precise and clear as possible. Clarifying your variable, the things that can be measured, the mechanism, basically the processes that are explaining the different relationship and definition of special terms relevant to your problem. You are likely to be asked why you chose the topic and why you used specific methods you picked, and all the others. So try to get it right. And on this, having a comprehensive literature review that is informed by a minimum of 40 research paper and up to 50 research paper will be setting you on the clear path when it comes to your proposal to even your final presentation, and even majorly informing your write-up. When it comes to crafting the appropriate method, the alignment key is that the method you choose should be aligned to your specific theoretical framework and the hypotheses that are derived from it. And the goal is to choose methods that will provide the clearest answer to your research questions. And the process of crafting a clear method are majorly in three phases. First, you have to choose the design of your study. Is it an experiment? Is it a correlation? Or is it a descriptive? In my final year project, as I had shared with a number of you, I was doing a correlational analysis of how urbanization is affecting water quality and water quantity. The next step is developing the measure and procedure for gathering data. Data collection is one of the key part when it comes to your project design and formulation. You will not want to be in a situation whereby you have chosen your specific topic of interest, to have done enough literature review on it, and you are in the process of now gathering data, and you just realize that whatever I'm trying to do has not probably been gathered by any specific organization, and you are stuck here trying to find out now what steps should I do. Choose method to analyze the data, to compare the finding even with the prediction. So choose the right method. And when it comes to GIS, you will think of a GIS approach, geospatial information system approach, or a remote sensing approach. Will you be using special query, the SQL? Will you be using scripting language to do your work? So you have to get it right when it comes to the methodology part. And you have to measure and generate data as the same grade size for your prediction to allow meaningful comparison. Try as much as you work. How can you be able to measure your work? Data collection, analysis, and even consideration. Data in our field, specifically for the GIS, we mention of the spatial data, but we also have non-spatial data. And that is not only limited to the numerical scores, it also includes the non-quantitative part, which include the written survey responses, interview transcript, and even journal entries, and some video recording, which will probably inform a number of literature work. Informing gathering in geomatics, we have the existing sources for the remote sensing part. You can use the USGS platform for Landsat related data. You can use the Sentinel platform. You can get Sentinel data as well as part of the spatial data for remote sensing. And we also have a number of other non-spatial data, which you may have to do some survey or surveying. Coding qualitative data, create coding rubric that will describe in detail how responses will be coded. When it comes to you designing a specific survey that you'll be collecting data from the field, the qualitative data, you have to ensure that you're well prepared for that. Ensure intracoder reliability, which basically is consider consistent coding by an individual, or intercoder reliability, which are consistent coding by different people using the same rubric. And you can use for mixed method for us as geomatics engineering for both the quantitative and even qualitative data to provide a more complete story. And this section, I titled it the evolving research paper. One of the best way of doing your write-up is you have to first write a draft of your paper while you are planning or conducting your study, not just as the end. As I was reviewing my research project, I wrote that I should have written the first 3 chapters even before being informed. And for you, as you are going through your final year project, one of the best way is to have your write-up done as early as you have gone through your proposal, So after your project has been accepted during your proposal, my take will be ensure that you do the first 3 chapters, and that will place you in a better position as time progresses. And even while you're writing, it will improve your thought process, and you will have your thoughts well organized, and even it will help you clarify your logic behind what you are trying to achieve. And you have to do a standard structure. And as I have shared with us, we have the write-up introduction. These are theoretical framework, data, and methods. We have results section, discussion, and conclusions. These 6 areas of a write-up, they are the standard structure within the geomatics field of JQuat. So you have to consider doing that, or ensure that you are in a position to fill up your write-up according to the 6 structure. Then integrate your literature. Your literature review should be an integral part of your theoretical framework, not a separate or a disconnected section. So as I have been mentioning again and again, your literature review is a key part, and my advice again, ensure you have 40 research paper, a minimum of 40 research paper up to 50. When you have 50, my take will be you're good to go. Ensure you can understand as much as you can from all those 40 research paper. And this parallel writing approach ensures that you have a coherence and an explicit connection between all parts of your study, and it makes even your work more logical and well justified. As we come to a conclusion, my final thoughts and perseverance section, as I have highlighted in my PowerPoint, research is an incredibly challenging but ultimately rewarding towards the end. One of the most beautiful parts about research is you being able to do your final presentation, and you are given a pass. You have gone through it. That's one of the most beautiful part when it comes to your project. And as I had mentioned earlier, your project makes up 300 marks. So it's an area that you considerably give much of your attention, because it's a whole 300 marks that you have the opportunity to change your grades and improve your GPA towards the end of your final year. You will have to expect some mistake and failure of productivity. This is an inherent part of scientific research and necessary step for deeper understanding and new possibility. You have to understand that and be open. Mistakes are just opportunity for us to improve on our existing work or on ourselves. So we should not take them as a kind of this is who I'm defined by, but it's an opportunity for you to work on yourself and even work on your research work and your academia goal. You have to actively seek feedback from specifically your advisor. Treat them as fair and honest critics, even if it feels harsh. There are some lecturers in our department, geomatics engineering. I should just say that you may feel discouraged, you may feel like you cannot do anything, but my take will be just go on with it. You have to develop your ability to, it's called resilience. You have to bounce back to your normal state. My take will not be, you will don't take all the harsh statement from them as a way, this is what I'm defined by, but take them as opportunity for you even to work on yourself and let them not define you. Persevere despite of the rejection and even substantive revision request. And as someone of like I was telling one of you that you can send, you can be given, you can be told to you have you have done your write up 60 pages up to 70 pages. You take it to your lecturer, and what you can see it's just a whole marks of red pen, and what is this, what is that, why this, why that, and your whole work 70, you have spent almost 2,000 printing that write up, and you're told this is rubbish, or let me just use the word rubbish in quotes, or um like stupid, like such words may be written in your write up, but you have to take courage and redo it again, not getting discouraged, and just advancing on and ensuring that it's part of the process and you are being refined for something bigger. And yeah, so towards the conclusion, that is it for today. If you have any questions, feel free to reach out to my email account, and also you can chat with me on WhatsApp. So thank you for having me.